6.4, solving word problems with systems of equations. We're going to be identifying the variables, which is very, very important when you're doing this. You need to write it down so that you don't forget by the time you finish your problem what you set up to be X and what you set up to be Y. So make sure you write that down on your piece of paper and identify your variables. And you're going to figure out which would be the best method for solving these systems of equations. So, let's go. All right, so when we're setting these up, you're going to identify and name the variables that outline the situation. So you want to ask yourself, what are we trying to find? Usually at the end of the word problem is what you're going to be looking for first. Read through it, but at the very end of the word problem, they're going to ask you a question. That's what you're trying to find. So that should be used with variables. And then the next thing you're going to do is write equations using those variables to describe that situation. Use the values in the problem that are given. So it may be helpful to draw a picture or walk yourself through a similar example in order to set it up. They like to use rectangle problems, so you may want to draw a picture of a rectangle. Either way, just whatever works for you. And then the last thing, choose a solution method and solve your variables. Always include units of measure in your answers. So if they're talking about inches, you need to say whatever your answer is, inches. If they're talking about feet, use whatever your answer is, put feet. So you're going to be setting this up whichever method you want to use, whether you want to use graphing, substitution, or elimination. It's totally up to you at this point when you're doing word problems. All right, so this problem starts out, let me move this out of the way. Find two numbers whose sum means addition, so you can write that on there if you need to. Sometimes it's helpful for people to write what we're doing. All right, whose sum is 18 and whose difference is subtraction, is 22. So you're going to have two equations. One of them is where it's going to be addition. One of them is going to be where it's subtraction. All right, so you're going to identify the variables. Okay, so you're going to be using X and Y. And it just depends on what you want to do. If you want to set up Y to be the first number, just write that down because at the end you'll forget which one you set it up. So let X be the first number because we're looking for two of them. And let Y be the second number. So I would want you to write this on your paper exactly like you see it. X is equal to blah, and Y is equal to blah. And that way you'll know what you've got, and at the end you'll be able to say, okay, oh, I've solved for this letter, so that means that is the first number, or whatever it is you're trying to look for. So remember, the question is, what are we trying to find? Two numbers. That's all we've got. It says find two numbers in your word problem. That's what we're looking for. Write two equations. So we're going to use X and Y. And the first one we're going to say they're adding because it says sum. Is always equals. Remember we talked about this earlier in the year. Is always equals 18. So that's simply written X plus Y equals 18. And then the next one says, the next part says, whose difference is 22. Okay, again, is equals. And so the difference, X minus Y, equals 22. So now you have your two equations, and there's just like we've been doing for the past 3 or 4 days, solving systems of equations. Remember your rules. You want to find one of them that has one of the letters, either X or Y, does not matter, that has the same coefficient, and you want to find one if it has the same coefficient to be positive and one to be negative. So we have that situation right here with the y's. Both of them have a coefficient of 1, and one is positive, one's negative. So we don't have to do any work to start with. Okay, so you just make it a big addition problem, just like over here. I've wrote it out for you. And the y's eliminate. Now, if you wanted to solve them for y and graph them, you could have done it that way too. Sometimes you can see different methods work faster. So then when you finish doing this one by elimination, you add your x's. That's 1x and 1x make 2x. They don't go away. 2x equals, and 18 plus 22 is 40. Divide by 2, you'll get x to be 20. Now, x was our first number, as we've got it up here. X is the first number. Then you just take that number, just like we were doing, and plug it into one of the problems that you did not change. Either one, it does not matter. So we plugged it into the very first problem. So I have 20 plus y equals 18. When I subtract 20 from both sides, I get y is negative 2. So my answer then is 20 and negative 2. Those are the two numbers that when you add them together, they give you 18, but when you subtract them, they give you 22. And you may want to go back and check your answers and just plug it in to make sure it works, but that is your answers, 20 and negative 2. So we used elimination on this one. I thought that one was the easiest one. A lot of you have expressed that you like elimination a lot better than substitution, but there are times when substitution works faster. Okay, so let's go to the next one. All right, the next one says the perimeter of a rectangle parking lot is 200 yards. The length of the lot is 16 yards greater than the width. Find the dimensions of the lot. So we've had rectangle problems before, and I would suggest drawing your picture. Okay, let's draw a rectangle. Okay, what they want to know is the dimensions of the lot. So they want to know the measures of all the sides. Okay, so it says the length of the lot is 16 yards greater, okay, than the width. So we just have to find x and y first. We need to decide which one we want to use. All right, so it says x is the length. Okay, so if you want to say x is the length, make sure you write it down. If you don't write it down and I come around, check your work, and you have a question, I won't even know where to start because you probably won't remember what you set it up to be. All right, and then y would be the width, because we are looking for the dimensions. That's the question. You're looking for the dimensions. So you're going to write two equations. All right, so we're going to have 2x plus 2y equals 200. Because it says the perimeter is 200. Remember, perimeter means you're going to add up all the sides. So if the length is x, I'm going to put that right there. That would mean this is also x, this is y, and this is y. So that is how we got 2y plus 2x equals 200, because they said the perimeter is 200. All right, and then it says the length of the lot, and length we used as x, is. So that would be x is, length is x, because that's what we decided it was going to be, 16 greater than the width. So 16 more than y. So that's how we set this one up. The length is x, is 16 more than the width. And that's how you get the second equation. That one's a little tricky, so you have to just think about it. Like I said, if you do not identify your variables, it will be very difficult from here to figure out what you're doing. So now that we have our two equations, we just decide which one we want to do. Now, on this particular problem, we have a variable that's already solved for an expression, and the coefficient's 1, so this one would be very easy to substitute in. Remember, substitution, we want one of the equations solved for x or y, does not matter, and then it's easy to plug in. So I would take this entire thing right here, and plug it into my top equation right here. One little pin crazy there. All right, so and that's what we're going to try. All right, so I took the first equation and I plugged in right here where it's in red what my second equation said x was. So remember, when you plug in, the variable that you're plugging in for goes away. If you still have two different kinds of variables, x's and y's, at this point, then you need to erase it and go back and do it again, because that's the whole point. You're plugging in and substituting for that other variable. And from here, we're going to distribute. So it's going to be 2y times 2 times y plus 2 times 16, which is 2y plus 32, plus 2y equals 200. Combine your like terms. your two y's. That makes 4y plus 32 equals 200. Subtracting 32, subtracting 32. That leaves me with 4y equals 168. Dividing by 4, that gives me y is 42. Okay, that's half the problem right there. Now, whenever we substituted, I told you to plug it into the equation that was solved for a variable. And then you have very little work to do at all. So you take this 42 and you plug it in right there. All right, so then 42 plus 16 will give you 58. So that means that if x is the length, that is 58, okay, and then the width is going to be 42. Okay? All right, so that means 58 is 16 more than 42, so that checks. And the two of them together, if you plug them in, that would make a total of 200. It would be 58 right here and 58 right here, 42 and 42. That would make a total of 200 yards, which is your perimeter. And if you plugged it in, 58 is 16 more than 42. So when you plug it in, remember you need to make sure you use your units. Our length is 58 yards. Our width is 42 yards. So again, it's very important to determine and identify your variables and mark them on your paper. If nothing else, mark that on your paper so that at least we'll know where you started. Okay? So that one was used in substitution, and that's because one of them was solved for a variable. All right, the next one says, you have a lot of these things. They like to use word problems with prices of tickets and prices of different things for like adults and children. You'll see these kind of problems a lot. So movie tickets, $6 for adults. Okay, and I suggest, underlining important information. $6 for adults, $2 for children. Okay, under 12. If there were a total of 175 tickets sold and $750 was collected. Now, again, the question is usually at the very end of the problem. How many of each kind of ticket is sold? So we're looking to see the number of tickets that were sold to adults and the number of tickets that were sold to children. Okay, so two different things we're looking at because they are charged differently depending on their age. So you can decide which one you want. Let X be the number of adult tickets. Okay, let Y be the number of children tickets. Okay, now when you're working with this and you're talking about number of coins and versus the amounts, you definitely want to make sure you write your equations when you're working with this very carefully, because money will always go with money and numbers will always just go with numbers. And you'll see what I'm saying in just a second. All right, so we're going to write two equations. We have $6 for an adult ticket, and we said X was the adult ticket. So $6, notice that's money, for the adult tickets, $2 right here for the children's ticket. So that's money, money. Then how much was collected money-wise? $750. So see, it goes money, money, money. All right? Make sure you watch that. That's all money. All right, and then it says how many of each ticket was sold. Well, we have adult tickets, we have children tickets, and they said a total of 175 tickets were sold. That's where you get adult tickets, children tickets, total bought. So 175 is not money. Okay, so make sure you always put the monies together and the other things together. All right, so this way, if you're looking at this, it would probably be easier to do elimination, although you could solve it for a variable very easily and plug in. Substitution would not be hard either. But let's do this one with elimination. So I wrote it over here. We're looking for the number of tickets each. So I wrote the first equation. Now I want to make that bottom equation look like the top. Okay? We really should multiply by a negative 2. So that'll be a positive addition problem. Let's go ahead and change that now. All right, so if I multiply by a negative 2, that will give me a way to get rid of the y's. Okay, so if I do that, I'm just rewriting the top equation again, and I'm going to have now a negative 2x, a negative 2y, and a negative 350. So we multiply by a negative to get opposite signs, and then we make it a big addition problem. Okay, so I ended up with 6x plus 2y equals 750. The top equation didn't change. The bottom one's negative 2x, negative 2y, negative 350, and make it addition. So when we do that, it's 6 plus a negative 2, which is 4x. The y's cancel. And then 750 plus a negative 350 gives us 400. When we divide by 4, x is 100. Okay? If x is 100, let's go back and see what we decided x was. X is the number of adult tickets. Okay? That is the number of adult tickets. So we need to know how many children tickets. So do we plug it into the money one? Or do we plug it into the one about the tickets, number of tickets? That's right, we plug it into the number of ticket ones. Don't get confused there, guys, because this is about money. And they may ask you, how much money did they spend on children tickets, or how much money did they spend on adult tickets alone? They may ask you that, but that's not the question we're answering. It says the number of tickets of each kind. So be careful. If they're asking about money, plug it into the money one. If they are asking about the number of tickets, you plug it into the one about just the tickets. So that was 100 of adult tickets. So we plug that in, and they did that right here. So 100 plus y equals 175. So y, of course, is 75. So they sold 100 tickets and 75 children tickets. You will be asked to explain your answer and separate it and answer the questions this way. So be prepared to be able to interpret what you've got when you finish, okay? You just can't have x and y and make it an ordered pair. That's not what they're asking you about with word problems. They're asking you to actually solve them. That's what we have systems for, is to actually solve real world problems, okay? All right, let's see if I have any more. Nope. All right, so if you have any questions, come see me in the mornings, or, when I'm available after school. We'll do lots of these in class and practice. These are not bad. Once you've broken down your word problem, it's very simple. And you've gotten so much better at these word problems because we've done so many this year. I don't think they're going to be quite as intimidating as they had been for you in the past. But the key is to make sure you write down what you set these up for, because one person next to you may have said, let Y be the adult tickets, and the other one might say, no, let's do that, or let's do this. You need to write down what you set each one for, so that way when I come around and look at what you've got, I'll be able to understand what you did. Okay, so please, this is the key, making sure you write down and identify those variables and put it down on a piece of paper, because by the time you get through all this, you may not remember what you did. All right, so we'll work on this in class. Come see me.